Figure shows the circuit for the half-wave rectifier without filter, and this is with filter. This is the tabular column. In the tabular column, we are going to see resistance VAC and the BDC.
So first let us do the half-wave rectifier. This is the transformer and this is the diode. This is what your resistance box. This is voltmeter. It is going to read both AC and the DC voltages. Let us do the connection. First transformer you are going to connect it to the main and other end is already connected. According to this circuit, what you have to do, so these two ends, first end is connected to the positive of the diode. Next, negative of this is connected to the load resistance. Negative of this is connected to the resistance box, and here from this end, that means the negative and the load resistance were connected. From this we have to connect it to the voltmeter. So from the negative of this we are going to connect positive of the voltmeter. Negative of the, you see in the circuit, negative of this voltmeter is connected to the negative of the resistance, and negative of the resistance is connected to the another end of the transformer. So in this way you have to do the connection. So after doing connection, make sure that all the resistance should be 0 except this 100 ohm. So here you can see, so all of you see here, all the resistance knobs should be equal to 0 except 100, make this is equal to 1. So by this, resistance is equal to 100 ohm. By keeping 100 ohm, here note down the values of DC voltage. Here you see in the voltmeter you are going to see the DC knob and the AC knob. So first you note down DC voltage. Here in the tabular column, the right here 100 ohm, write the DC voltage. What is the DC voltage? 5.90. Right here 5.90. Next change this knob to AC. Note down this AC voltage. It is 7.47. After note downing DC value and the AC value, note down calculate the ripple factor by substituting AC and the DC. Similarly, the experiment should be repeated for the 200, 300 and the 400, 500. Let us see first another one example. What is the value you are going to get for the 200? For the 200, what is the DC voltage? DC voltage is 6 voltage, and next change this knob to AC. So what is AC? It is 7.60. And once again calculate the ripple factor by using this formula for the 200. The same procedure is repeated for 300, 400 and the 500 and calculate the ripple factor. Now start the second part of the practical. What is this? This is your half-wave rectifier with capacitor. What is the difference between this and this? Only one capacitor you have to insert in between the diode and the resistance. So what you do means just you take the two wires and you have to connect this from the negative of the diode to this capacitor, and the second end of the capacitor should be connected to the second end of the transformer. And after doing this one, you have to repeat the same procedure from the all the resistance should be 0 and this should be 100 ohm. And for this 100 ohm, once again you have to note down the DC value and the AC value. Now you see, after putting the capacitor, you are going to get the DC value is here. The DC value is 10.81, and you write here 100 ohm. And what is the AC value? Change this knob for the AC value. You are going to get the AC value is 4.55. And next the procedure is repeated for the 200 ohm. Change this for the 200. Note down the DC and the AC value. What is the DC value? It is 13.1. And what is the AC value? To note down the AC value, change this knob to AC. It is 3.11. What is the resistance value? 200 ohm. The same procedure is repeated for the 300, 400 and the 500. And after, note down the AC and the DC voltage, calculate the ripple factor by using the formula VAC by VDC. Next part is do the calculations for the ripple factor. So I will show you one calculation. What is the formula for the ripple factor? Ripple factor is equal to VAC divided by VDC. Where you have taken the VAC and VDC? Here. So for the 100 ohm, what I got AC is 4.55 and DC is 10.81. Let us do the calculation. So by using the calculator, let us do the calculation. 4.55 divided by 10.81. So what we are going to get, it is 0.42. So it is 0.42. Let us write it is 0.42. Similarly, you are going to calculate for all the resistance values, that is from 100 ohm to 500 ohm. And finally find the average of this one.